Welcome back. We're going to continue with the Unit 2, Chapter 5. We're going to go with Section 5.3, and these are the targets or goals for this lesson. After this lesson, you will be able to add, subtract, and multiply polynomials, and you will also be able to use the above properties to solve real-world problems. Make sure you have these in your notes, and everything else we do in this lesson is ready to be checked tomorrow. Okay, adding polynomials. You can only add polynomial terms if they have the same base, same variable, and those variables have the same exponents. And the only thing you're adding are the coefficients. Okay, so with this one, 5r squared minus r minus 8 plus r squared minus 6r plus 2. Like terms in these two polynomial expressions, one pair is 5r squared and r squared. So I can do 5r squared plus 1r squared. And another pair of like terms is negative r and negative 6r. So I can add negative 1r plus a negative 6r together. And in this case, we have one more pair. These are constant terms, polynomials, remember that. Negative 8, so plus a negative 8 plus 2. So we're just going to combine like terms individually. What is 5r squared plus 1r squared? Is it 6r to the 4th power? If you thought that, you are incorrect. We only add the coefficients. If we identify two terms to be like terms, the variable stays the same, we add the exponents. 5 plus 1 is 6r squared. Negative 1r and negative 6r added together. Well, it's a negative 1, really, that's a 1 there, don't forget that. Plus a negative 6, that's a negative 7r, r squared. And negative 8 plus 2, that would be plus a negative 6. And I don't like to have two signs like that next to each other when I'm simplifying things. So if it's a plus and a minus, plus or minus, it just is negative 7r. If there's a mix of each, it's just negative. If there's both the same signs, it's positive. That's the way I keep track. We've just combined those terms that way. Okay? So really adding or even subtracting polynomials, we're going to get to in a minute, is just combining like terms. It's nothing really all that new. So let's look at this one. Let's move my box out of the way here. Make the 3n cubed minus 2n squared plus 3n minus 2. Subtract n cubed minus 13n squared minus 4. Now here's my trick. You can subtract these terms individually, but what I like to do is change it to an addition problem. And how do I do that? Is I distribute that negative sign to every term inside. So all that does is flip the sign inside, or multiply it by negative 1. Negative 1 times n cubed is negative n cubed. Negative times negative is a positive 13n squared. Negative 1 times negative 4 is a positive 4n. So all it's done, essentially, is flip the signs. And why did I do that? Well, essentially, we turn that into an addition problem. So it's just like what we did in the last slide. It's the same thing. I'm going to show you another way I like to do it. We did kind of a horizontal addition. Some people like to line up the like terms. So if I rewrite this problem, do it in blue, what I'm going to do is I'm going to take all these terms and I'm going to stack them underneath. N cubed goes underneath the 3n cubed term. Plus 13n squared goes underneath the negative 2n squared term. Plus 4n, excuse me, not 4n, plus 4. Okay, that was a plus 4, not a 4n. I added that in there by mistake. I'm sure you're all wondering where the n came from. Just realized I made that mistake, but we're back on track. That happens occasionally. That's why I always look back over your work, because once in a while, even I make a mistake. Hard to believe, I know. 3n cubed plus 1n cubed is 4n cubed. Negative 2n squared plus 13n squared is 11n squared. 3n has nothing underneath of it, nothing to combine, so we just say plus 3n. It's like adding 0. And negative 2 plus 4 is 2. And notice when I'm done, I want it to be in standard form. This one happened to be in standard form because the left polynomial was in standard form already, so when I line things up, they're in standard form. But if it happened to be that it wasn't highest degree to the constant or lowest power, you would want to reorder that when you're all done. Okay, but that's subtraction. That's the trick I do, is I turn it into an addition problem by distributing that negative sign first. Technically, if you want to just subtract each term from its like term, left to right, you can do it, but a lot of people mess up, and once they do it with the first n cubed term, and then they forget to make that a double negative for the negative 13n squared and the negative 4. So just my little hint, turn it to it, you distribute it right away, make it an addition problem. Okay, multiplying by a monomial. That's distribution. We've done that already. We did that last chapter. This should not be anything new, because really quadratics, they are polynomials. So a lot of these things we've done already, we've experienced. So I'm just going to multiply 3t by everything in the parentheses. 3 times 2 is 6. T times t would be adding the exponents. 2 plus 1 is 3. T to the third power. Remember those properties we learned? Yep, we're going to use them still. 3 times negative 7 is negative 21. T times t is t squared. 3t times negative 5 is negative 15t. That's it. Make sure it's in standard form. This is t cubed, t second, t to the first power. Standard form. All done. Now, multiply these polynomials together. This is the vertical method. I really would not call it the vertical method. I'd call this the box method. So we're going to cross off vertical, and we're going to call it a box. Remember the box method? Okay. The box method, basically, what I mean by that is, remember, we take a polynomial, doesn't matter. We'll say 3n minus 2. That'll be one side of our box. And then the left-hand side will be n squared minus 4n plus 6. So when we do this, we're just going to fill in each box by multiplying each individual box. So maybe call it I said box, or maybe the table method. I've said that before, box or table. Either one, it's the same thing to me. N squared times 3n is 3n cubed. N squared times negative 2 is negative 2n. Negative 4n times 3n is negative 12n squared. Negative 4n times negative 2 is 8n. 6 times 3n is 18n. And 6 times negative 2 is negative 12. So what happens once we fill in those boxes? We combine the like terms. What I like to do is stack them out. So 3n cubed minus 2n, what I mean stack them up is stack them up so they're like terms, or line them up. 2n. So negative 12n squared, that doesn't have a like term, so I'm going to kind of put it between these two. But 8n is like terms with the 2n. And 18n, oops, negative 12n squared, forgot the square there. 18n minus 12. So if we look at this, that's what happened here. Oh, let me go back on that. Where did I mess up here? Negative 2 times n squared is negative 2n squared. Oops, so it should have been negative 2n squared. I made a mistake there. Look at that already. Second mistake of the whole year. Okay. So they should have lined up like that. I missed that too. That's what happens when you go fast. So I was just showing you guys not to go fast, right? When we line them up, we have the like terms. We just add vertically. 3n cubed has nothing alike. Negative 2n squared and negative 12n squared is negative 14n squared. 18n and 8n is 26n minus 12. And there's our polynomial. So make sure you're not going really fast like I just did and miss a term. That's why I was going to go back and check it. That's what I did. I'm like, that doesn't make sense. When I went back through, I checked, I saw where my mistake was, I fixed it, and I adjusted. So even though it wasn't an intentional mistake like I was pretending it was, it is kind of a good thing, because what happens when you make a mistake, when you're doing your homework, you're not going to have me to check it and look it over. You're going to have to be able to do the same thing I just did to evaluate what you did wrong and fix it, because nobody is going to do every problem perfectly every time. You got to be able to check your work. Okay, so that is the box method. Okay, here are some special products. Some differences: square of a binomial and cube of a binomial. First, let's look at the sum and difference. That means x minus 4, x plus 4. Notice it's the same thing, except one's a plus, one's a minus. Same terms. That's what it means, sum and difference. We multiply them together. What happens? We've done this before. Let's go back to the old FOIL method. When we're doing that, just for everybody that really likes FOIL, first, outer, 4x, inner, negative 4x, and last, negative 16. What happens that's cool with this one when it's sum and difference or pattern is the middle term drops out. We get x squared minus 16. Okay? Difference of squares is another way to say this. Difference of squares, right? That's what you end up with. Down here, difference of squares. Oops. Difference of squares way down here. Okay? So that's kind of that pattern. The middle term cancels out when we multiply. Square of a binomial. Square of a binomial, 2x minus 4 squared. Well, really, that's 2x minus 4 times 2x minus 4. What's that going to create? It's going to create a perfect square trinomial, right? You do the box method one more time to show that I can actually do it correctly the first time. 2x times 2x. I know you all have to make that. It's 4x squared. 2x minus 4 is negative 8x. Negative 8x positive 16. 4x squared minus 8x plus 16. I get 4x squared minus 16x plus 16. So perfect square trinomial, right? Same thing. That's what. We factor this, 4x squared minus 16x plus 16, we get 2x minus 4 squared. Definition of a perfect square trinomial. Cube of a binomial. How do we do that? This is the new thing. Right? Everything we've done so far should be repeat information. This is new. We got to remember that x plus 4 cubed is really x plus 4 times x plus 4 times x plus 4. It is not x cubed plus 4 cubed. Just like x plus 4 squared wouldn't be x squared plus 4 squared. It is not. No, no, no. That's not what we do. So how do we multiply 3 things at once? It's a trick question. Nobody can multiply 3 things at once. You can only do 2 things at a time. So what I do is I just pick 2 of these binomials and I multiply them together. So maybe I FOIL it. Maybe I use the box. Okay, well, let's just, for argument's sake, we FOIL this first one. X squared plus 4x plus 16. So I FOIL it out. I get x squared plus 8x plus 16. Normally we'd be done, right? But we still have this x plus 4 that needs to get multiplied again. So you kind of have to FOIL twice or use the box method twice. So maybe I FOIL the first time, and then this time I'm going to use the box. Is that okay to do? It's perfectly legal to me. You just have to do it correctly, that's all. I like when we get trinomials and bigger and we're multiplying, right, a binomial or another trinomial, you choose the box because you don't get lost, you don't miss pieces. So once I get a trinomial, I go to the box. That's just me. X times x squared is x to the third. X times 8x, 8x squared. X times 16 is 16x. 4 times x squared is 4x squared. 4 times 8x is 32x. And 4 times 16 is 64. List things out. get these two expressions stacked on top of each other. X cubed, 8x squared plus 4x squared is a 12x squared. 16x plus 32x is a 48x plus 64. And we've now multiplied 3 trinomials together. Okay? So to multiply 3, you're going to have to do FOIL/box table method twice. Okay? So rewind that if you have any questions. Play it again. Here's one for you guys to try. X plus 2 times x minus 4 times x minus 1. I want you guys to, I'm going to pause it, or you pause it on your end, and you try multiplying these out and see if you get the same thing I get. Okay, so we just said you can't multiply 3 things in a row together all at once. You have to pick 2 and multiply them together. So I'm going to do x plus 2 times x minus 4. Let's FOIL these first ones again. X squared minus 4x plus 2x minus 8. X squared minus 2x minus 8. Remember, I still have this x minus 1 that I still have to multiply by. So we bring that down. We got a trinomial times a binomial. It's box time for me, table time, whatever you want to call it. If you want to try and FOIL it, you can do it. The quote-unquote FOIL method, it's not really FOIL, once you get a trinomial. It's the same principle. It's just you're more likely to miss a term that way. I remember I would do that rushing all the time. This way, it's a lot easier to catch your mistakes if you rush, as noted earlier. X times x squared is x cubed. X times negative 2x is negative 2x squared. X times negative 8 is negative 8x. Negative 1 times x squared, negative x squared. Negative times a negative makes a positive 2x. Negative times a negative makes a positive 8. Combine our like terms by stacking them up. And we get what? Well, x cubed has nothing to add to. Negative 2 and negative 1 make negative 3x squared. Negative 8x and 2x make negative 6x plus 8. Hopefully that's what you got, because that would be the right answer. Okay. So after completing this lesson, hopefully you agree that we've mastered these 2 targets, that you are able to add, subtract, and multiply polynomials, and you're also able to use those properties to solve real-world problems. Now this one we haven't done yet. The last one I will agree with that, but we kind of did the skills today. Tomorrow we'll bring this target with us, and we will apply them on some story-type problems or more real-world type problems in class. So have your notes, have the concrete ideas down, and we will hopefully extend them in class for you tomorrow. Make sure all these notes are down. If you had any questions or issues, rewind it, go back through it, fast forward the parts you need, so you have everything mastered by tomorrow. Have a good day.